Hello everyone! Today we're going to learn about solving problems involving quadratic functions. My name is Shaina Marie Marañon and I will be your teacher for today. So we can recall that quadratic functions are of the form f of x is equal to ax squared plus bx plus c. Problems requiring minimization or maximization are solved using quadratic functions. So how do we find the minimization or maximization of problems? So extremes of quadratic functions. Recall that graphically, the maximum or minimum value of a function can be found through the vertex of the parabola, which is hk. The maximum or minimum value of the quadratic function is the value of k, where k is equal to 4ac minus b squared over 4a. The extreme value of a quadratic function is the ordinate k of the vertex. So let's have some illustrative examples in solving problems involving quadratic functions. The sum of two numbers is 48. Find the maximum product of the two numbers. So we have the solution. First, we let n be the first number. 48 minus n be the second number. We let f of n be the product of the two numbers. So we have f of n is equal to n times 48 minus n. So equal to n times 48 is equal to 48n, and n times negative n is equal to negative n squared. So we have our quadratic function f of n is equal to 48n minus n squared. The maximum value of the quadratic function is the ordinate k of the vertex of the quadratic function. To find k, we are going to use the formula for k, which is k is equal to 4ac minus b squared over 4a. So in f of n is equal to 48n minus n squared, we have the value of a is equal to negative 1, b is equal to 48, and c is equal to 0. Now we're going to substitute the value of a, b, and c to the formula. So we have k is equal to 4ac minus b squared over 4a is equal to 4 times negative 1 times 0 minus 48 squared over 4 times negative 1 is equal to negative of 48 squared over negative 4. So we have the answer 576. Therefore, the maximum product of the two numbers is 576. So let's have another example. A ball is thrown from the top of a 144-foot building. The ball follows a trajectory. The height h reached by the ball after t seconds is given by the quadratic function h of t is equal to 64t minus 16t squared. How high did the ball reach? So our solution, the maximum height that the ball reached is the value of the ordinate k of the quadratic function h of t is equal to 64t minus 16t squared. To find the maximum height that the ball reached, we use the formula k is equal to 4ac minus b squared over 4a. To find k, in the quadratic function h of t is equal to 64t minus 16t squared, we have a is equal to negative 16, b is equal to 64, and c is equal to 0. Substituting the values of a, b, and c, we have k is equal to 4ac minus b squared over 4a is equal to 4 times negative 16 times 0 minus 64 squared over 4 times negative 16 is equal to negative 4096 over negative 64. So the answer is 64. Therefore, the maximum height that the ball reached is 64 feet. So let's have our last example. A 5 centimeter by 5 centimeter square is cut from each corner of a rectangular piece of cardboard. The sides are folded up to make an open box with a maximum volume. If the perimeter of the base is 50 centimeters, what are the dimensions of the box? So we have our solution. So we have the figure which shows the rectangular piece of cardboard being cut by a square 5 centimeter by 5 centimeter from each corner. So we let W be the width of the box. Then we have perimeter is equal to 2 times L plus W. Given the perimeter of the base 50 centimeters, we have 50 is equal to 2 times L plus W. Dividing both sides by 2, we have 25 is equal to L plus W. To get L in terms of W, we have 25 minus W is equal to L. So we have 25 minus W be the length of the box, 5 be the height of the box. And we have V of W is equal to L times width times height, which is the volume of the box. To find the maximum volume of the box, we substitute the values of the length, the width, and the height to the formula. So we have V of W is equal to 25 minus W times 5. Simplifying, we have 5W times 25 minus W. So we have 125W minus 5W squared. So our quadratic function is V of W is equal to 125W minus 5W squared. From the quadratic function, we have the values of A, B, and C. So we have A is equal to negative 5, B is equal to 125, and C is equal to 0. To find the maximum volume V of W of the box, we are going to substitute the values of A, B, and C to the formula of K equals to 4AC minus B squared over 4A, which will become 4 times negative 5 times 0 minus negative 125 squared over 4 times negative 5, which will be equal to negative 15,625 over negative 20. Simplifying negative 15,625 over negative 20, we have 3,125 over 4. So the maximum volume of the box is 3,125 over 4 cubic centimeters. But what is asked in the problem are the dimensions of the box. So now we are going to find the dimensions of the box. To find the dimensions of the box that will have the maximum volume, we are going to use our quadratic function V of W is equal to 125W minus 5W squared. Substitute the value of V of W, which is the maximum volume, 3,125 over 4. So the equation becomes 3,125 over 4 is equal to 125W minus 5W squared. Multiplying both sides by 4, we have 3,124 is equal to 500W minus 20W squared. Changing the equation to its standard form, we have 20w squared minus 500w plus 3125 is equal to 0. Dividing the equation by 5, we obtain 4w squared minus 100w plus 625. Factoring the equation, we have the factors 2w minus 25 times 2w minus 25 equals to 0. So 2w minus 25 equals to 0. So we have w is equal to 25 over 2, which is equal to 12.5. So we have the width 12.5 centimeters. To find the length, we substitute the value of the width to 25 minus w. So we have 25 minus 12.5. So we have 12.5 centimeters. So our length measures 12.5 centimeters. Then we have our height 5 centimeters. Therefore, the dimensions of the box with the maximum value are 12.5 centimeters by 12.5 centimeters by 5 centimeters. That will be all. Thank you for watching, and I hope you have learned something.